The main purpose of today's discussion is to understand what are the data interacting with the PLC from the field. So let's start the discussion. This is a PLC or DCS, and this is a pressure transmitter in the field which is reading, sensing some pressure from the compressor inlet or discharge side. Similarly, differential pressure transmitter is also installed in the compressor suction side or discharge side, and through which PLC or DCS reading through electrical signal 4 to 20 milliamperes. So instrumentation associated with the surge controller. One, we should know the pressure transmitter or differential pressure transmitter. Second, we should know what is the differential pressure transmitter, that is for the flow measurement. So differential DP for flow we should know. Another is a pressure boost or compressor boost, compressor final discharge pressure minus compressor section pressure. So how data is coming to PLC and DCS? So let us understand this. Surge control can be configured either in PLC or DCS. So it can be configured either PLC or DCS. Let us understand how instrument works. Every instrument sends 4 to 20 milliampere signal from transmitter to PLC or DCS through input card. 4 to 20 milliampere signal is converted to engineering value through programming. Also, these values are also converted to raw value or percentage for calculation, and logic development is done in PLC or DCS. For reference, these are for example for understanding how engineering values and raw value is calculated in PLC or DCS. Let's say one pressure transmitter is sending signal to PLC or DCS, another differential pressure transmitter for the flow is also sending signal to PLC or DCS. So pressure transmitter we call it PT, and differential pressure transmitter is called PDT of the flow transmitter FT. Let's understand the range of PT is 0 to 10 bar. So this range of this transmitter is 0 to 10 bar gauge, and range of PDT, which is flow FT, which is 2500 mmWc. Let's say PLC received electrical signal of 8 milliamperes for PT and 12 milliamperes for PDT. Then engineering values for these data would be, how we can calculate. For pressure transmitter PT, for this range of electrical signal we know 4 to 20, that means 20 minus 4, which is 16 milliamperes. Range of PT 10 minus 0, because it's 10 and low is 0, so 10 bar. So engineering value is equal to range of PT into PLC signal minus 4 upon range of electrical signal. So since range of this PT is 10, so 10 into reading is 8 milliamperes, so 8 minus 4, it is signal minus 4 upon range means 20 minus 4. So on calculation it is coming 2.5 bar. So if PLC receives 8 milliamperes, that means this means it is 2.5 bar is the pressure in the pipeline. For differential pressure transmitter PDT of FT, range is 2500 minus 0, which is 2500 mmWc. Engineering value will be range of PDT into PLC minus signal 4, PLC signal minus 4 upon engineering range of electrical signal. So what is the range of PDT? It is 2500 into 12, which is the signal which is PLC is receiving, minus 4 upon 20 minus 4, which is coming as 1250 mmWc. That means 12 milliamperes is corresponding to half of the range. So we can quickly say if 4 is receiving, that means 0% of the range. 8 milliamperes is 25% of the range, and 12 milliamperes is the half of the range, that means 50% of the range. 16 milliamperes means 75% of the range, and 20 milliamperes is 100% of the range. This is the understanding of milliamperes corresponding the range of the transmitter. Now converting these data into a raw data, considering range of raw data is 10 to 16384. For pressure transmitter, range of electrical signal again 20 minus 4 is 16 milliamperes. Range of raw is 16384 minus 0 is 16384. And raw value is equal to range of raw into PLC signal minus 4 upon range of electrical signal. That means raw value will be 16384 into 8 minus 4, because 8 is the signal which PLC has received, minus 20 minus 4, which is coming at 4096. Similarly, for the PLC pressure differential transmitter PDT of FT, range of PDT is 2500 minus 0 is 2500 WC. Raw value is equal to range of raw data into PLC signal minus 4 upon range of electrical signal. That means 16384 into 12 minus, sorry, it is off, it should not be off, 12 minus 4 upon 20 minus 4, which is coming as 8192 raw. Now PLC and DCS has raw data as well as engineering data for internal calculation and logic development. So based on the logic, controller will generate output signal which will go to anti-surge control valve to operate. So 4 to 20 milliamperes output signal will generated to control valve positioner, where it is converted into 32 psi for controlling the instrument air to operate the valves. So this PLC or DCS will give the output to the anti-surge control valve based on the logic, which logic is adopted for the surge control, and this 4 to 20 signal again converted into pneumatic signal, and then opening the valves is used. How this will go, how PLC will generate signal, output signal to control valve or anti-surge control valve. So this is called the PID. It is a soft logic development called as a PID, means proportional integral. P means proportional, I means integral, and D means derivative controller. So in short, it is written as PID. And so develop in PLC or DCS. It is a soft signal, soft logic being developed at PLC or DCS. So input data normally it is process value is PV, set point is SP. And then based on this it will compare what is PV, which is more or which is less, and based on that it will generate output, which is again 4 to 20 signal. Of course PID will generate 0 to 100%, but PLC card output will give 4 to 20 signal to the control valve. So one controller output, this is one control output. Output of PID controller will give command to anti-surge control valve through 4 to 20 signal, LK signal to position anti-surge controller will operate based on this signal. And process value and set point are calculated based on the surge logic. So we'll discuss in coming lecture or on the surge part how different logics or algorithm has adopted for surge control, and based on the process set point this is working and output generated, and this will operate the anti-surge control valve. So thank you. With this I have finished my lecture. Hope you like this. If it is so, please subscribe my channel, like it, share it, so that you will get the intimation of new video. See you in the next session. Till then, bye bye. Thank you.